With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question given is which of the following statements is true? So we need to check true statements. So first statement is diethyl ether is better Lewis base than diacetyl ether. Okay, so let's see. First of all, we have dimethyl ether. Dimethyl ether means we have CH3O CH3. This is our dimethyl ether. Now we have diethyl ether, diacetyl ether. Diacetyl ether is SiH3, okay, and here oxygen and SiH3. So this is diacetyl ether. Now how we check the Lewis base? So Lewis base means, suppose we have any Lewis base BH. This is our Lewis base BH, suppose, and having lone pairs. It must have lone pairs, okay. When it will react with acid like H plus, suppose we have H plus, so the donating tendency of lone pair to this H plus, if more, then Lewis basicity will be more. So the basic concept is, this is a Lewis base, it has to donate the lone pair to the H plus. So after donating, what we get? We get BH2 plus. Sorry, BH2 plus. We get BH2 plus because boron donate the lone pair to H plus. Now, in this question, we only need to check the Lewis basicity. Which one is more, having more Lewis basicity? So, how we check Lewis basicity? The donating tendency of the lone pair to the H plus is called basicity. So, basicity is the lone pair donating tendency to the H plus. So, here also we have lone pair, and here also we have lone pair. But here silicon having empty d orbitals. Silicon having empty d orbitals, so that's why this lone pair is delocalized with empty orbital of silicon. That's why this lone pair is not available to H plus. Suppose here H plus is come to accept the lone pair, because I told you Lewis basicity is the electron donating tendency to the H plus. So here this oxygen will not donate the lone pair to H plus easily, because its lone pair already delocalized with the empty orbital of silicon. But here we have oxygen. So here we have carbon. Carbon do not have any empty orbital. So that's why this lone pair is available to donate H plus. So this oxygen can easily donate the lone pair to H plus. So that's why its Lewis basicity will be more, its Lewis basicity will be less. Okay, so this statement is correct. Dimethyl ether is having more Lewis basicity compared to diacetyl ether. Okay, because in this diacetyl ether, the lone pair is delocalized with silicon empty orbital, so that's why it will not available to donate H plus. But in dimethyl ether, lone pair is localized, it is not delocalized, so it is available to donate H plus. So that's why its basicity will be more. So first statement is perfectly correct. Dimethyl ether is better Lewis base than diacetyl ether. This is correct. Now CH3 whole thrice COH is less acidic than CH3 whole thrice SiOH. Okay, so let's see this question. We have two acids, so CH3 and thrice, and what we have here? Okay, here also we have COH. Okay, so here C and here we have OH, and other compound we have CH3 whole thrice and SiOH. Okay, we need to check the acidity. So let's see. First of all, draw its complete structure. So here we have carbon having CH3, and here CH3, and here also we have CH3, and here we have OH. Okay, let's draw its structure also. So here we have silicon and methyl, and one methyl CH3 and one CH3 also here, and here we have OH. Now we need to check the acidity, so that's why we need to form conjugate base. So make its conjugate base. How we can make conjugate base? Remove proton. So proton remove, it donate the electron here and negative charge generate here. It will also donate the electron here and negative charge generate here. So their conjugate base should be like this: CH3 and C, and here CH3 and here CH3, and here we have O minus. Now its conjugate base CH3, Si, CH3 and CH3 and O minus. Now We only need to check the stability of their conjugate base. If conjugate base more stable, then acidity will be high. Okay, so here this negative charge will not do any resonance. Okay, it is very unstable because of plus I of these methyl groups. These methyl groups operate plus I, so they will destabilize this anion because anion is destabilized by plus I groups. Okay, they will increase electron density here. That's why this anion is already having electrons, so it is destabilized. So this conjugate base is very unstable, but this conjugate base is very stable because silicon having empty orbital. So here silicon, okay, I'll write it like this. Okay, I'll write it here. So here silicon having empty orbital. So here we have CS3, and here CS3, and here another CS3, and here we have O minus. Now silicon having empty d orbital. So that's why this negative charge can do back bonding in empty d orbital of silicon. That's why this is a delocalized. It means here resonance is possible. This is called back bonding resonance. So this negative charge is delocalized with empty orbital of silicon. That's why it is more stable. Okay, this conjugate base more stable because it is stabilized by resonance, or we can say back bonding. So that's why this negative charge is more stable, or we can say this conjugate base is highly stable by back bonding because empty d orbital of silicon. But carbon do not have any empty d orbital. So that's why this conjugate base very unstable. Okay, so this statement is correct. So statement saying that CS3 whole thrice COH is less acidic than CS3 whole thrice SiOH, because this is correct because this is more acidic. Why? Because in empty d orbitals the negative charge will do back bonding. So that's why its conjugate base more stable. So if conjugate base more stable, then acidity will be high. So that's why this is less acidic than this. So both are correct. So both statement A and B are true. So option number C is correct here. Thanks.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.